Last up for multiplying special products, we have the square of a binomial, okay? This one is a little bit deeper. It's not quite so straightforward, but this is very, very important. At some point in your math future, you're going to talk about completing the square. This comes up just completing the square to solve what's called a quadratic equation. You also need to know this when you deal with circles. So at some point in the future, you may deal with circles. So this is going to be something that's a bit more important. It's a bit more in depth. Okay. So first of all, when you have the square of a binomial, that means you have a binomial in parentheses, obviously, and then you're going to square that. So essentially, you're taking that binomial and multiplying it by itself twice. Okay. So the square of a binomial, let's say that the binomial is just made up of two terms, a and b. So if we have a plus b and we square it, that gives us a plus b times a plus b. You're just taking that binomial and you're squaring it. What I do want to point out off to the side is a plus b quantity squared is not equal to a squared plus b squared. It does not work this way. You can bring the exponent inside when you're dealing with a product, but not a sum, okay? Instead, your entire base is a plus b. So you have to take a plus b and multiply it by itself. So you really must understand this right here also. If you have a minus b quantity squared, it does not equal a squared minus b squared. Instead, if you have a minus b squared, it equals a minus b times itself twice. Okay, so know that first of all. Now, if we were to FOIL this out, we'll see a pattern emerge. So if I have a plus b quantity squared, remember that's a plus b times a plus b. If I were to complete the FOIL method, I would take the first terms, which are the a's. Well, a times a is a squared. I would then take the outer terms, which would be a times b, so I get ab. I would then take the inner terms, which is ab again, okay? So a times b, ab again. And then finally, I take the last terms, which is always going to be plus b squared. Well, now those middle terms, they don't cancel anymore. It's just double. Okay, so you end up with a squared plus 2 times the product of the middle of the two terms, and then plus the second term squared. So notice what we have here. We have the first term squared. We have the product of the two terms a and b doubled, and then we have the last term of that binomial squared. Okay, so the first term squared, the product of the two terms doubled, and then the last term squared. That's the pattern that has emerged. Now let's do the same thing, but this time we're going to look at the difference of those two terms. So this time we have a and b again. We're subtracting them. So we have a minus b squared. So remember, that's a minus b times itself. Okay, so if we were to FOIL the first term a, well, a times a is a squared. The outer terms would be a times negative b, so we get minus ab. The inner terms would be negative b times a, which is again minus ab. So you see that middle term, it doubles itself. And then finally, the last terms would be the second term, which is just b. But negative b times negative b is again positive b squared. So when we combine, notice those middle terms, they don't cancel like they did with the difference, like when we were dealing with the conjugate pairs. Here, when you're multiplying the exact same terms by themselves, so a plus b times a plus b, or a minus b times a minus b. So you don't change your signs, keep the sign the same. Those middle terms, they don't cancel, it doubles. Okay, so notice again the pattern that's emerged. We took the first term, which is a, and squared it. We took the second term, which is negative b, and squared that. We get our plus b squared at the end. And then you take the product of a times negative b, which is negative ab, and you double it. So you take the first term and square it. You take the product of the two terms, double it, and then you take the last term and square it. And that's the pattern that emerges, okay? So when we look at that special product formula, okay, we have a plus b squared. So we know to take the first term and square it. We take the product of the two terms, so a times b, and we double it. And then we take the last term, b, and we square it. For a minus b squared, we take the first term, a, and square it. We take the product of the two terms, so a minus b, is a times negative b, so negative ab, and we double it. And then you take the last term and you square it. So negative b times negative b is positive b squared, okay? So first term squared, you multiply the two terms and then double it, and then you take the second term and square it, okay? So for the first couple of these, we're going to do just like we did in the previous example. We're going to use the FOIL method first just to prove to ourselves, hey, this really is true. And then for the last one, we'll use the special product formula. These special product formulas are really time savers, okay? Okay, so for example, 3, it says find each product, write the answer in standard form. So we're going to make sure that we understand that this is x plus 3 squared, okay? Or x plus 3 squared is x plus 3 times x plus 3 is what I should have said. If we do the FOIL method, we get x times x, which is x squared. We then do x times 3, which is 3x. 3 times x is 3x. 3 times 3 is 9. The middle terms combine, we get x squared plus 6x plus 9. So let's really think about that. The first term was x, we got x squared. The second term was 3, we got 3 squared. The product of x and 3 is 3x, and if we double it, we get 6x, okay? So the special product formula really would work here. And what you need to know is this right here, this trinomial is called a perfect square trinomial, and you will definitely see this again in your future. You will see it when we learn to factor. We're going to learn how to factor perfect square trinomials. When we solve these things called quadratic equations, we're going to learn how to solve them by completing the square, which involves a perfect square trinomial. When you at some point in your future talk about circles, you end up completing the square, which involves these perfect square trinomials. So this idea of a perfect square trinomial comes back up, and it's very important. If you take the square root of your first term and take the square root of your last term, those first have to be perfect squares. The first and last term have to be perfect squares. But then if you take the product of these two things and then double it, that has to equal the middle term, which it does, okay? So when you multiply a binomial by itself, so you square a binomial, you always end up with this very pretty perfect square trinomial at the end, which is very important later down the road, okay? So again, for part B, let's go ahead and do the FOIL method just to prove to ourselves this works, and then for the last example, we'll do the special product formula. So x minus 5 squared is x minus 5 times x minus 5. I need to do the FOIL method. So first terms, x times x is x squared. Outer terms is x times negative 5, which is minus 5x. Inner terms, negative 5 times x, which again is minus 5x. Last terms, negative 5 times negative 5 is plus 25. The middle terms combine, so we get x squared. Negative 5x minus 5x is negative 10x. And then we drop down the plus 25. So this right here is a perfect square trinomial. And we know this is a perfect square trinomial because it's supposed to be an A. If we take the square root of x squared, we get x. If we take the square root of 25, we get 5. So the first and last terms have to be perfect squares. They are. And then if you take the product of the square roots of the first and last term, so 5 times x, and then double it, you get 10x, which is the middle term, okay? So just know this idea of a perfect square for sure comes back, okay? Now for this one, we've got a binomial squared, okay? So instead of doing the FOIL method, let's just trust the process. We take the first term and square it, so this is going to become a squared. So that's 2x times 2x, which is 4x squared. We take the last term and square it. So that's going to be negative 1 times negative 1, which is plus 1. Okay. We multiply a and b, and then we double it. So a times b is 2x times negative 1. So that's negative 2x. We double it, which is negative 4x. And this is our final answer. Okay. And we can say that this is definitely a perfect square trinomial. If we kind of work backwards, we have the square root of 4x squared, which is 2x. We have the square root of 1, which is 1. If I take 2x times 1 and then I double it, well, 2x times 1 is 2x. And then 2x times 2 is 4x, which is the middle term, okay? So we have covered kind of a good bit here. So remember, the square of a binomial, you quite literally take an entire binomial and square it. Make note that this is never going to be the case. So really understand what's happening when you square a binomial. If we were to use the FOIL method, that's fine. You could always use the FOIL method, but this is a shortcut. You FOIL and you end up getting this nice format right here. So we see this pattern emerge. So that becomes our special product formula. And just know that the final product is the final result, the final product is a perfect square trinomial, okay? So these are going to come up again when we learn how to factor polynomials, and then again when you're dealing with completing the square, which is a method for solving quadratics.